We've been asked to find reference angles for these 7 examples. Just looking at them, you'll notice some of them are in degrees and some of them are in radians. If one of these problems starts in radians, we're going to answer it in radians, and if one of them starts in degrees, we'll answer it in degrees unless we're asked to do otherwise. What I like to do is I like to just draw a picture of each angle, identify where the reference angle is, and then see if I can think of what that value would be. In our last video, we went through a lot of trouble to think up some formulas, but I actually don't memorize these formulas. I draw the picture every time and then try to think about what the reference angle will be. And so a 357 degree angle, I know is a almost 360 degree angle, so it's down here in the 4th quadrant. If I just think about what's left over between there and the full revolution, I'll know that theta bar is 3 degrees. In fact, when I go to draw that angle, what I'm really thinking is that it is almost a full revolution. Well, how much less than a full revolution is it? It's 3 degrees less. That's the intuitive process a lot of us probably use when we even draw it, and it's like we're hardwired to find that reference angle. 5 pi over 6. Every time I'm asked to draw a 5 pi over 6, what I'm actually thinking about is that it is, well, it's not quite 6 pi over 6, right? Well, that would be the straight angle, pi radians. And so 5 pi over 6 over here in the 2nd quadrant. Well, how far away from 1 whole pi is it? Well, it's pi 6th, and that's my reference angle. Right, this little angle right there is pi 6th radians. All right, so now we have to rotate the opposite direction. All right, we have a negative angle. Minus 120 degrees would be about here, down in the 3rd quadrant. Well, if I rotated minus 180 degrees, I'd end up right here, meaning that this reference angle has to be 60 degrees. Minus 4 pi thirds. Well, minus 1 pi third would be here, minus 2 pi thirds, minus 3 pi thirds, and then finally minus 4 pi thirds. Well, when I got to minus 3 pi thirds, I was right here. 1 more pi thirds in the negative direction gets me there. And all I have to do is remember that my reference angle is always a positive acute angle, so it must be pi thirds. All right, on this next one, I have to be careful. I have theta equals 5, but there's no degree symbol, so I have to assume that this is an angle measured in radians. Maybe intuitively you already know what quadrant that lives in, but just in case, we could use our graphing calculators to say, well, in degrees, that would be 5 times 180 over pi is 286.5 degrees. So if I wasn't sure about what quadrant I was in, now I am. I'm going to answer this in radians, but finding that degree measure just made me feel a little bit more confident about my drawing. So now I think about that angle theta bar being this angle right here, where my angle is just shy of a full revolution. So I'll say that's 2 pi minus 5 radians. 2 pi radians minus 5 radians is about 1.28. 1.28, and I'll say 32 radians. I wasn't told how to round it, so I'll just round to 4 decimal places because it feels right in the moment, and hopefully if this was a graded assignment, we'd be told how to round it. All right, alpha is equal to 580 degrees, beta is equal to 8 pi over 3. What I notice right away is that's more than 1 full revolution in these 2 problems. And so I can think about this angle alpha. 360 degrees gets me to right here. To get to 580, that's 220 degrees more. All right, so my angle is something like that big 580 degree angle. But right away, I can kind of think about taking 360 away from it and realizing that a coterminal angle would be 220 degrees. Well, 180 gets me to there, leaving 40 to be that reference angle. All right. Oh, and that's not a theta bar. My angle was alpha, so this is an alpha bar. It's a reference angle for alpha. All right, one more to worry about. Beta is 8 pi over 3. All right, well, 1 full revolution gets me to 2 pi, and I'm thinking to myself that that is 6 pi third radians. All right, so 7 and then 8 pi thirds over here in quadrant number 2. All right, well, again, I could find that coterminal angle, right? Take 2 pi away from that, that's 6 pi thirds, and that's 2 pi thirds, leaving 1 pi third to get all the way to pi, and that's my nice, happy reference angle, pi over 3. All right, so that's how we can find reference angles, just by drawing little diagrams and thinking about what is left over to get to the x-axis. That's it for now.